This semester in Chem 3AL, we covered different methods of purification and different methods of analysis in which we get mixtures and try to separate them into their separate components. The ones we'll be looking at in this video are column chromatography for purification and thin layer chromatography for analysis. And these methods and many others are used widely in many research labs and in the biotech industry to purify biochemical products and mixtures of both lipids and proteins. Okay, so first I'm going to talk about column chromatography. So how does that work? So I have a column at the bottom with a stopper to control the flow of whatever I put in it. And I fill it up maybe about halfway with the stationary phase, which pretty much helps separate your mixture into whatever components you want. Then after the stationary phase, you put in your actual mixture. And after the mixture, you put the mobile phase, which is usually an organic solvent. And what that does is it pretty much carries the mixture through the stationary phase and out through the bottom. And the stationary phase is typically a gel or something that it's like a solid. So you don't want it to drip out and come out of the tube. So what you do is you put a little disc at the bottom to kind of keep the stationary phase in the column. The only thing that should be coming out is the mixture and the mobile phase. And at the top, you have a funnel, to help you keep everything in the column. Column's pretty thin, so you don't want anything spilling out. And what usually helps in this is to kind of use an air bulb at the top and apply pressure to it on the sides to increase the air pressure in the column to make the mixture go down the stationary phase a little quicker. But you want to make sure that when you press down on the bulb before releasing, you want to pull it up, and so that you don't pull up the stationary phase and what's actually in the column. That'll screw things up. So when you put the mixture and the mobile phase in, as you're applying pressure, it'll go down the stationary phase and split. Your mixture will split into its separate components. And based on what you use as the stationary phase, you'll get different results. You can use gel filtration, which separates by size, ion exchange, which separates based on charge, or reverse phase, which separates based on polarity. And which one you use is based on what you're trying to extract out of your mixture. So at the bottom, as this is dripping out, you're collecting all this at the bottom. And what you want to do is you're going to want to collect a lot of them. You're going to collect them in fractions so that this mixture, as it's dripping out, you're going to have a little bit in each of these. Now, why is that? Is because as this is dripping out, you're going to have the components in this mixture are moving down the stationary phase at different speeds. So you'll have one component come out first, and then the other components will come out soon after. So you'll have all of these fractions of the components. And then once we have these, we can use TLC analysis to see how pure our compound is. So we have a TLC plate. And like the column chromatography, we'll have a stationary phase. Typically it's silica. And it's just a hard material that's embedded on a piece of plastic that helps separate the actual compounds. So this is all going to be within a beaker with very, very shallow, small amount of the organic solvent, which was the mobile phase. And after you want to make sure that this solvent line does not get below what we call the origin, which is where you place small amounts of the actual mixture on to separate. So after you have these fractions here, you're going to get a little bit of each and kind of dot them. Put a tiny amount here and a tiny amount here on each of these little tick marks that you're going to mark with just regular pencil. And aside from these fractions, you're also going to have some of the original mixture usually on the first lane here. And that's just to kind of use as a comparison model to see how pure these two are and what components are still linger in these. So after you put this in the beaker, you seal it up so that the organic solvent doesn't evaporate. And then over time, you'll see the components kind of split. And they'll kind of move up at different speeds based on either polarity or by size or whatever method you use. So I'm just giving you an example here. Say this is the original mixture. It's separating into 3 components. So you know there are 3 components within this mixture. Getting the first fraction that eluted, you're going to have that one compound come out first, and that's going to be the majority within the first fraction. So you get that. And what you're going to see is that component that came out first is going to be pretty much the only thing that you're going to find in the first fraction. The second fraction may or may not have more of that, but if it does, you'll see that you'll have two pure fractions in which you can get those first 2 fractions and kind of throw them together to a bigger beaker, and you have a bigger beaker full of that pure component, that pure compound that you extracted. So you repeat this and you try to identify which fractions have just a single component, and then you gather all those components and then you throw them into a larger vial and collect your pure component. And that's how you not only separate your mixture, but also figure out which fractions that you extracted have the pure components, and then you have your finished pure component.